Okay, so welcome to the exam one review for intermediate algebra. And so just a reminder of things. You can always come back and access this by going to our online math resources for students. Open that up, and then you will open up the dashboard for our course, which is intermediate algebra. And from there, right in here in test review materials, you can see that, well, this is the old iMath AS, so ignore those. We don't want those. But if you come right over here and you click on My Math Lab Reviews, you can see that we're working on version B right now. So version A is already there. This is the blank document. This is the solution. This is the video. Okay, so we have a version A for all of our exams. And right now we are working on the version B. So if you want to see what the blank document is or download it, it's right there for you. And all the other blank versions are coming along. So this is the blank document that we're going to be working from. We are working on the solution guide for it right now, and we are working on the video right now. As soon as this is all, as soon as the video is done, I will get the solution guide out there, and the video will get posted as soon as we get the link for it. So that's where you can access all this great information. And again, make sure that you are on the My Math Lab tab if you're working in My Math Lab. If you're working in iMath AS, then you go to the iMath AS tab. Okay? Because under the iMath AS, we already have two versions of each kind. And with that note, let's get ready to rumble. Those are my notes. You don't need those. All right, here we go. This is the better stuff. Hide my floating keys. So this is going to be my answer document that we're working on. Here is our review. So the first thing you're going to see in the review, question 1 and 2 are all coming from compound inequalities. So our sections on compound inequalities. And if you look at the first one, what kind of compound inequality do we have? Oh, this is where you all participate. What kind of compound inequality is it?
And, right?
It is an and, yes, because it says and between it. Yeah, it's an and. If you look at number 2, what kind of compound inequality is that one?
Or.
It's an or. See? Easy peasy. All right. So also, so you know, for your answers, these answers are going to be in interval notation. I know it says set there, but they want interval notation, just like the homework. If you have been doing the homework in My Math Lab, these are all the same kind of questions in the same way that you answer them. That's where we get these from. Okay. So this is going to be in interval notation, although I will talk about both because it's important to know both. All right. So we know it's an and. Where do ands normally shade? If I had a number line, where would an and normally shade on the number line?
The middle.
In the middle, that's right, because usually you're stuck between two numbers. Ands normally shade in there, and that's what we hope is going to happen. Okay, so let's check it. Let's find out if we shade in the middle. So all we're going to do is solve this inequality the way it is. So how do I solve x plus 3 greater than or equal to 3? What do we do?
Yeah, x by itself or no?
Okay, so let's get x by itself. How do we do it?
Subtract 3.
Boom. Minus 3, and it's because of this 3, not that one, this one. We want to get everybody away from x. That gives us x greater than or equal to, what's 3 minus 3?
0.
0. So there's part of our answer. That's, well, let's say this is part of what's gonna help us get to the answer. All right, so we're gonna come over here. We're gonna solve this guy. So how do we get x by itself again? What are we gonna do?
Plus 9.
Yay, add 9, add 9. 5x greater than or equal to 1 plus 9 is
10.
10. You guys are killing this. You don't even need me. Now what are we gonna do?
You divide by 5.
I love it.
Yes, divide by 5, divide by 5. X, what is 10 divided by 5?
2.
2. Yep. Now the question is, when it comes to division and multiplication, you need to be careful. Is this sign gonna stay the same as a greater than or equal to, or will it flip and become a less than or equal to? What's gonna happen here?
Isn't it stay the same?
It's gonna stay the same, because the only time we flip this sign is if we're dividing or multiplying by a negative number. This number is positive, so it stays. So here is the information we need to graph on a number line. So remember, a number line goes from smallest to largest. So what number comes first?
0.
0 is our first one because that's the smaller number of the two. Then obviously this has to be a 2. Okay, so let's graph x greater than or equal to 0. So at 0, is this going to be a bracket or a parenthesis?
Bracket.
It's going to be a bracket. And the reason it's a bracket is because we have the line underneath it. We're equal to. So it's going to be a bracket. Okay, will it shade to the right or to the left?
To the right.
To the right, follow the arrow. As long as your variable's on the left, follow the arrow. So that one looks like this. Whee! Sound effects included. All right, let's talk about 2 and let's graph it. Bracket or parenthesis at 2?
Bracket.
Bracket. Shade to the right or to the left?
Right.
To the right. Whee! There we go. All right, now we like ands shading in the middle, but remember sometimes that doesn't always happen. So let's talk again. Why do ands shade in the middle? Well, what are ands really after? When we look at an and answer, what are you really trying to look for?
Where they intersect.
Where they intersect. In other words, where they overlap. So I'm doing this on paper, but if I could take these two graphs and take this one and push it up on top of the other one, so they lie on top of each other, where is it I would have both graphs?
2, 0.
Starting at 2 and going where?
1.
Going
Or-
to 1? 1's back here.
Infinity.
Going to infinity. It's
Oh,
going
yeah.
this way because this is where they overlap.
Okay.
So we would have a bracket down here and shade to the right. So this is what our graph really looks like. All we have to do is put that into interval notation. So interval notation, where does our interval start?
Bracket
0.
to
Bracket 2. Yes.
infinity.
It starts at the 2 and our graph shoots out towards the arrow, which is infinity. Now in infinity, is that a bracket or a parenthesis?
Parentheses.
Yep, you both got it. This is the answer they're looking for. If we had to put this in set notation, it would look like this. Our brace, our variable is X, vertical line, and then we need to put this as an inequality, like up here. So we know that we have from 2 on up, right? My graph is from the number 2 on up,
Yes.
and we like the 2 because it's a bracket. So that means as an inequality, it would look like x greater than or equal to 2. So if it asks for the set answer, that's what it looks like, just so you know. I like to talk about both because it's important that you know both. Okay?
Mhm.
So normally ands shade in the middle, but unfortunately, this is one of those weird cases where it's not in the middle. Because normally and answers start with a bracket and a parenthesis, and then you have your lowest number. And then you have a comma, then your large number, and then another bracket or parenthesis. That's how a normal and answer looks, where you got 2 numbers. But again, we're not stuck in the middle, so it's a different type of answer looking. Questions on number 1?
No.
Okay, let's jump to number 2, our second compound. So as you told me a moment ago, this is an OR. I'm writing it down real quick. Just bear with me a moment. Okay. So we're doing the same thing again. Let's talk about an OR. Where do ORs normally shade?
In the opposite direction?
Yeah, in the opposite directions. I call it the outside. So ORs normally go out here. Okay, or and shade the inside or shade the outside. So let's solve these. Let's get x by itself. How do we solve number 2 real quick? What are we gonna do?
Subtract 9.
Subtract 9 minus 9 minus 9. X is less than, and that would be negative 9. Because 0 minus 9 is negative 9. All right, so here's a piece that's going to help us. What do we do over here? How do I solve this inequality? 3x greater than negative 9.
Divide by 3.
Divide by 3. Divide by 3. Divide by 3. So x is greater than, what is negative 9 divided by 3?
-3.
And I didn't want to put this sign in there, but I did because just my brain goes on autopilot sometimes. It stays greater than. Because again, what are we dividing by? We're dividing by a positive. We don't care if the numerator's negative. It's when the denominator, when you're dividing by a negative number, that's when we flip that sign. Everyone good so far?
Mhm.
All right. So let's graph this and then talk about what the answer is. Who's our smallest number?
-9.
Negative 9. So we got negative 9. And then after that, we've got the negative 3 over here. Okay. So at negative 9, bracket or parenthesis,
Parentheses.
shade to the right or to the left?
To the right or left?
Follow the arrow to the left. So this looks like this. Bracket or parenthesis at negative 3,
Parentheses.
right or left?
Right.
To the right. All right. Does this kind of look like an OR answer?
Yes.
Absolutely. Because when it comes to ORs want wherever there is shading. So my answer, wherever there's shading, that's my answer. So my answer includes this side, which is our negative 9, and my answer includes this side. If my shading overlapped, that would have been a-okay. Like for instance, up here, if I was to graph an OR answer, I would have had a bracket at 0 and shaded this direction. Even though they overlap there, that's okay. Because ORs say, give me an answer wherever there is shading. I want everybody. So an OR answer to this one would have started at 0 and went to positive infinity. So again, the difference between ands and ors. Ands are all about where they overlap. Generally, that happens in the middle. Ors are all about give me everyone. Wherever there's shading, I want it. And ors are generally to the outside, which you can see our answer is to the outside. All right, so let's talk about an OR interval answer. Remember, with OR intervals, you have a parenthesis or a bracket. Sorry, no. Forgive me on that. OR answers have to start with a parenthesis. This is why we don't write in pen, because I have to use whiteout now. Pen is the devil. All right. OR answers start with a parenthesis most of the time, negative infinity, comma, your number, which is the smallest, and then it is a bracket or a parenthesis, depending on your sign. And remember, these get a union symbol between them. And then another bracket or parenthesis. This time it's your large number, comma, infinity, parenthesis. Or answers generally look like this. So let's write this up. You know it's going to start with a parenthesis. What comes next?
Negative infinity.
Yay.
And then it's a -9.
-9 bracket or parenthesis.
Parentheses.
Yes. Then what?
The U. The denote.
The U. But just know that this is a union symbol. It is not a capital U. If you type in a capital U on the exam, it's going to count it wrong. You need to make sure that you use those symbols that happen. Remember, when you click on the square, there's a list or kind of like an extra help that pops up below with all those symbols. Make sure that you're using their union symbol. Do not type in capital U. It'll be wrong.
Okay.
Then what comes next?
Is it negative parentheses?
Parenthesis.
-3 to infinity.
Yay. And on the end,
Parentheses.
parenthesis. There's our answer. That's the interval. If you did set, it would look like this. So our brace with X and our line, and then all you're going to do is write down these two answers with the word or between them. And then close it. So there's the or answer, because we want both of these answers. Any questions about our compounds? The first two questions are your compounds right out the gate. Everyone good? I'm going to take silence as a yes.
I have a question.
I have an answer.
So mostly on the exam, or mostly on the homework, they asked for like interval notation. They didn't really ask for much set notation. How much of the exam is going to be, if that's an appropriate question, set or interval?
Oh, you can ask. Well, what did you just see right there? Did we have to really worry about set?
No.
No. Okay. What you see when we do this review is what your exam is going to be like. All that's going to happen, I'm going to go in and change numbers. That's it.
Okay.
So the way you answer on here, same way you're going to answer on the exam.
Awesome.
All right. So number 3, absolute value. We are solving the absolute value of 2x minus 5 equal to 7. And again, all you're going to do in here is you're just going to type in the two numbers, because remember, absolute value has two answers, because there are two numbers that are a distance of 7 away from 0. So you'll type in two numbers and use a comma to separate them.
You have to find the positive and negative for this one?
Well, they both could be negative answers. They both could be positive answers. It all depends on what happens with this equation. So you have to be careful. I'm hesitant to say that you have to find the positive and the negative,
Okay.
but you do need two answers. This should be a 2-number answer, not 1, 2. So let's talk about that. If there are 2 answers, then that means there are 2 equations. The first equation you all are really good at getting. It's the second equation that tends to kick the booty. So let's talk about the first equation. What does this first equation look like? How do we get it?
Don't you plug in?
No plugging in. I
It's
just
right
wanna know-
there. It's
Add
given
Say it
to us.
again.
It's right there. It's given to us. We dropped the
It's gi-
absolute value stuff.
There it is. That's what I was looking for. Yeah, just drop the absolute values. That's why I said usually the first equation is good. You guys are good to go. It's right there. It's given to you. Just drop the absolute values. That's the first equation. This is what we got to solve. So let's go ahead and do that.
You add 5.
Okay. Add 5. 2x is equal to what?
12.
12. And then what?
Divide by 2.
Okay. X is equal to?
6.
There is one of our answers. All right. How do we get the second equation? This is
Does
the
it
one that trips up.
become -7?
So what becomes -7?
The 7 over there.
All right. So basically, all you're going to do to get the second one, and you're right on track, drop the absolute value and make the right half its opposites. So a +7 became a -7. To get the second equation, drop the absolute value, drop it like it's hot. Take the opposite. All right, so let's solve again. What are we going to do?
Add 5 to both sides.
If you notice, really, you're going to do the same steps. Just the only thing that happened is we changed the sign right there, which in the end will change our answer. -7 plus 5 is -2. Now what?
Divide by 2.
Okay. X equals,
-1.
-1.
and there's our 2 answers. All you got to do is type in -1, put a comma, type in 6, done.
Does it matter what order it goes in?
Well, let's find out. That's where you should always read the blueprint. So it says, looking down here, nope, it doesn't matter the order. So I could put 6, -1. But just so you know, as good mathematicians, rule of thumb, always put it in order.
Awesome.
Yes, because once I put it like 6 and 1 like out of order, and it counted as wrong. They in the math lab, and they counted as wrong. So
Email me that kind of thing so I can look at that, because if that happens, I go back and fix it. Ain't no worries.
okay.
If
Oh,
my
okay.
math lab is being kind of weird like that, email me about that.
Okay, because it's been a couple of times when I put the answer the way it is, and just because I put it out of order, it just counted as wrong.
Well,
Yeah.
if it wants the order, it should tell you to put your answers in order there. If it doesn't say that, then it shouldn't be counting it wrong. But just so you know, rule of thumb in general, mathematicians always put their answers in order. All right. So here we're going to graph. All right. But before we can graph, notice it says it wants you to write your equation as a function. All that is saying, remember that f of x, what did I tell you f of x really represents?
Why?
It's y. All they want you to do is solve this for y. Okay? Solve this for y. So let's do that real quick. So how can I get y by itself here?
Subtract 2x.
Subtract 2x. Good. Move the x away from the y. So that's going to give me -8y equals, And now you can write this one of two ways. You can put the 8 minus 2x, or you can put negative 2x plus 8. I always like to write my x first. But there is nothing wrong if you put 8 minus 2x. So if you have it looking like this, there is nothing wrong with that. That is a-okay. Now what?
Subtract 8.
Nope.
Oh.
Divide
Divide. What are we going to divide by?
8. Divide by
Negative
y,
8.
and then divide the whole thing on the other side.
Yeah. And so most professors will say, just put a line there and slap the negative 8 underneath. But I like to make it that really what you're doing is you're just dividing the numbers by negative 8. Because we want this separated out. So now we have y equals, what's a negative divided by a negative?
Positive.
So this is a positive. Now you got to reduce the fraction. What's 2 over 8 reduced to?
1/4.
Perfect. So that is 1/4 x. What's 8 divided by negative 8?
-1.
There you go. So if you also wrote it like this is perfectly a-okay. So again, if you kept it in this form and divided everybody by negative 8, your end answer would look like -1 plus 1/4 x. Remember that putting f of x in here means the same thing. This is what I would put into that blank. And again, there's nothing wrong if you have this as well. It will not count it wrong, or should not. Okay, that's a-okay. So this goes in the blank. Now let's go back to the question and let's look at the graphing now. So in here, it says use the intercepts to draw the line. Okay, so this is what in my courses, I talked about the BAM method. Hopefully I kind of gave you a heart attack on that, because that's supposed to. Because usually if we were in a face-to-face class, I would be hitting the board with my hand at the same time too. So you're going to use the BAM method on this. So in order to graph, they want us to use the intercepts, just so you know. So let's talk about that. Let's talk about that BAM method. So if I want to find the x-intercept, who do I BAM? Who do I cover up?
You multiply 8y by 0.
Okay, that's right. Because if I want the x-intercept, what's going on is that we're looking for a number, comma, 0. And that means that the y value in here is going to become 0. This is why I call it the BAM method, because I come in here and I cover it up. And all that I have left to solve for is 2x equal to 8. What do I do to get x by itself?
Divide by
You
2.
put a 0 on y.
Well, we already did that.
Oh,
That's
well,
why I
yeah,
BAM'd
you
it.
divide now.
Divide by 2. There we go. So I'm not going to plug in the 0 for y. I'm just going to cover it up, because I know that that's going to just go away, because anything times 0 is 0. So my x-intercept is 4, comma 0. I'm going to use that to help me graph. Okay. If I want the y-intercept,
You'd set x to 0.
that's right. So we'll come up here and we'll go bam, it's gone. Because again, the x in the y-intercept is 0, and you're looking for the y value. So we have negative 8y equal to 8. So how do we solve for the y-intercept here?
Divide by -8.
Divide by -8. Divide by -8. So y is equal to
-1.
-1. Now we know our y-intercept is 0, comma, -1. I have 2 points. I can definitely draw a line between them. Okay. So let's talk about how the graph is going to work for you for number 4.
Isn't this one the one that we could also plug in the thing that we did in the graph calculator?
You can,
Like with
but
the
just make,
line.
yeah, you can, but just make sure that you are graphing it the way they want you to. Okay. And they want you to graph the intercepts. All right. So make sure that you do that. So when you get your graph, when you're ready to graph, remember that in my math lab, once you click on the graph, our little toolbar will show up down below. So let me draw a quick graph, and I don't need a very big one. Five, 5, 4, 5, 4, 5. Give me just a moment. Just writing in what I need on my graph. Okay. So here's my graph. I just went to +5, -5, +5, -5. Because looking at our intercepts of 4, 0 and 0, -1, it doesn't have to be that big. So remember that when you're in my math lab, when you click on the graph, our little toolbar shows up down below. And there's a clear button. There's an arrow button. There's a dot. There's a line tool. And if you look at the line tool, you see 2 dots on it. Okay. And then there's a lot more stuff there going on. So when you're doing this problem, you click on the line tool, and all you have to do is plot those 2 intercepts we just found. So I click on my line tool, and I come up here and I plot 4, 0. So I click, and remember that as I move my mouse away, that line will show up and will follow your mouse wherever it goes until you make the next click. So my second click is at 0, -1. As soon as I click that point, the line is solid and is done. So remember, it takes like 3 clicks in here. Click on the line, click your first intercept, scroll over, click the second one, and you're done. So as I connect the 2 dots there, as best as I can, got a nice little ruler I can use to cheat a little bit. That's what the line should look like. So this is the other point on number 4 with your graph. Any questions so far? So again, number 4, it wants you to write the equation. So take the standard form and turn it into slope intercept. That's what's going on. And then find your intercepts and use those to graph. Cool beans?
Awesome.
Awesome sauce. All right, moving on. So that one right there, that one came from when you were graphing functions. This one came from when you were graphing functions. And yes, if you have a graphing calculator, you can come into your graphing calculator and you can find those intercepts. Let me open up my graphing calculator real quick. If you're using Desmos, because you can use Desmos too, you can find the x-intercepts on Desmos really, really easy.
You said
Yes.
for the exam, there's only the online notes, right?
Yes, the notes that I provided you for my class.
Okay. So if I'm writing everything that you're saying right now, it's not, it's gonna be good to study, but it's not gonna be, I can't use it on the test.
Correct.
Okay, cool.
So our equation was 1/4 x minus 1. So if I go to graph, there I can see the x-intercept, or sorry, the y-intercept of -1 or 0, -1. And over here, I can see the x-intercept of 4, 0. And if you just want to verify that, because you might double check, oops, let's change that up. Table set. Yours won't be like mine. That's from a previous class. So now if I go into the table. So there you can see, there's the x-intercept. And now you can see on the table, there's the y-intercept. So you can use your graphing calculator to help you out. There's nothing wrong with that. All right, jumping back, let's talk about number 5 now. So number 5, it wants you to find the slope and the y-intercept.
Is the slope already given, or do you have to?
The slope is not already given in this.
Okay.
So you're going to do the same thing right here on number 5 as what we just did on number 4. And we need to get the y value by itself, because you can only determine the slope of this as long as your y value is by itself. Okay, right now this is in what we call standard form. We need this to be in slope intercept form. So how do we get the y value by itself?
Moving the 6, so minus 6x.
Yeah. So y equals -6x plus 11, because I like to put my x variable first. But again, if you wrote it like this, y equals 11 minus 6x, there's nothing wrong with that. And since there is no number in front of y, we don't have to worry about that division step like what we did in number 4.
Mhm.
So now that we are in slope intercept, that's what this is. You can tell me the slope and you can tell me the y-intercept.
Is the slope -6?
The slope is -6. And for the y-intercept, you should always read the fine print. Let's go back and look at that real quick. So it says for the y-intercept, write in ordered pair. So that's important. So they don't just want the number, they want the ordered pair. So again, remember, a y-intercept is written as 0, a number. What is that number?
Is it 11?
It is 11. So our y-intercept is 0, 11. Because remember, when you're in slope intercept, we call it slope intercept because it gives you the slope and the intercept. That's what B is. It is the y-intercept. 11 is the y-intercept. So that's all they want in number 5. Tell us the slope, tell us the y-intercept. Number 6. So again, you learned that information in the graphing linear functions section. Graphing linear functions section. You also reviewed it in the slopes section as well too. Slopes of linear equations, linear functions. All right, number 6, they want to know if these are parallel, perpendicular, or neither. So we got this f of x equal to -6x plus 7. We've got this equation g of x equal to 1/6 x plus 9. How do I determine if lines are parallel, perpendicular, or neither?
For parallel, they have the same slopes
Good.
and different y-intercepts, right?
Yes. So
And
all we really need to know for this one, parallel, is that the slopes are the same. Same slopes.
And then for perpendicular, isn't it the product of the slopes have to be -1?
That is true. Or in other words, what we say is the slopes are opposite reciprocals. Opposite reciprocals. Or in other words, it means change the sign, flip it. That's what opposite reciprocals mean. Change the sign and flip it. If you're not one of these two, then you're neither. So in order to know if these are parallel or perpendicular, I need to know their slopes. What's the slope for f of x?
-6.
Perfect. What's the slope for g of x?
1/6.
1/6. Good, because both of these are in slope intercept. If they were not in slope intercept, like above, we would have converted it. So based off of what you see here, are they parallel, perpendicular, or neither?
Perpendicular.
They are
Perpendicular.
perpendicular. They are perpendicular. Because remember, this slope of -6 really looks like -6/1. And so if I take the opposite of a negative, I get a positive. So that's good. And if I flip this, I get 1/6. So they are opposites, reciprocals. Does that make sense?
Yes, sir.
Yes. Good. All right, number 7. And just so you know, there are only 20 questions on this. Every one of your exams will be 20 questions. All right, number 7. So it says, decide whether a line with the given slope slants up, down, or is horizontal or vertical. So we have a slope that is undefined. So what does the line look like for an undefined slope?
Is that vertical?
That is correct. Anytime the slope is undefined, you have a vertical line. So the answer is A. A horizontal line will be when your slope is 0. Just to review that with you. A line that slants downward means that the slope is negative. A line that slants upward means that the slope is positive. Okay, since this is not a number, can't be those two. Any questions on number 7? All right, number 8, we are writing the equation of a line that goes through those 2 points. So how do we do that?
Do you put it in point slope form?
I would love to use point slope, but I can't until I get what first?
The slope.
The slope. We got to have a slope first. Can't do anything without the slope. Do you remember what the equation for slope was?
Y2.
Oops,
Keep
bad.
No, you go ahead.
Y2 minus,
Y1 over X2 minus X1.
yay. So all we have to do is plug in. And I like to label my points. I think that helps you. So remember, points are made up of X and Y. Just the question is, which one is the X1, Y1? Which one of these is the X1, Y1? Which point?
-3.
You got it. And the 16. Those are our ones because that's the first point, hence the 1. Since this is the second point, they get the 2s. Okay. So now you know who is who. All we got to do is plug in. So Y2 is 21. minus my y1 is 16. My x2 is -4 minus, because of the formula, my x1 is -3. You need both of these.
So what'd you add?
This is because of the formula. This is because the number is negative.
So
But like what you were saying, Nick, what happens with two negatives by each other?
you have to add them, right?
You got it. So this really looks like 21 minus 16 all over -4 plus 3. So what is 21 minus 16?
5.
5? What is -4 plus 3?
-1.
So what is our slope?
-5 or 5 over
-5.
Yeah.
You can call it 5 over -1 if you really want to work with the fraction, but I'll just call it -5. Because 5 divided by a -1 is -5.
And then
All
you
right.
get the point slope form.
Now we're going to use that point slope. So remember, point slope looks like y minus y1 equals your m x minus x1. So in here, you're going to put your point. Now remember, when I talk to you in class, and as other professors would tell you using point slope, that you need to pick one of these 2 points. It doesn't matter which one you pick, you will get the same answer. My advice to you, pick the point that has the smallest numbers. So which point do you think Mr. Armstrong would pick?
-316.
Absolutely, I would go with this one. It's the smaller of the numbers. But there is nothing wrong with this one. I could have worked with -4, 21. But I'm just going to go with this guy. And lo and behold, it's my x1, y1 anyway. So y minus, what's my y1?
16.
16 equals my m, which is -5, parenthesis x minus, what's my x1? -3. So there's what it looks like.
Do you have to do the double add again?
So yeah, we're going to talk about that right now. So again, this is because of my formula. That's why that minus is there. This is because that's my number. Be careful of that. The problem that happens with algebra students is that you think that there's a minus here and this negative are the same thing and you only do one of them. But they're not. This is because of the formula. This is because that's for the number. You need both of those. So yes, Nick, you are correct. We get y minus 16 equal to -5 parenthesis x plus 3. So now all we got to do is just keep cleaning up. So what are we going to do now? Because we got to get this in slope intercept. Y equals.
Distribute the -5.
Yes, good, Catherine. Distribute that -5 through. So that gives us -5x minus 15. And over here, we still have y minus 16. And now what? One more move.
Plus the 16.
Yepers. And that 16 will get added on to the end. So we end up with y equals -5x, what?
Plus 1.
Plus 1. There's our equation. Any questions so far? So this one is coming from the writing linear equations section. And the same thing for number 9. We're writing a linear equation. And this is the one that usually in my class, I always warn students about. This is one of those most missed questions. And it's on ACTs and SATs. And it's a most missed question. So we want to, again, write the equation of a line that goes through this point for -6 and is perpendicular to this equation. Okay. So in my classes, I do kind of like a setup for this. So in my classes, I talk to them about the setup, and it looks like this. You're dealing with two lines here. You have a line 1. You have some sort of relationship between them. And then you have a line 2. What do I put under the line 1? What do you remember, those of you that have?
4, -6.
Not the 4, -6.
The slope.
We want the slope in line 1, but the slope of what?
The first one. The first line.
The first line. And who's the first line?
4, -6.
No, that's a point. That's not even a line.
Okay.
Well, we have to find it.
We have to find it. Yes, but who are we finding? What? Give me the part that I want. Who do we have to look at to find the slope of?
The y and x intercepts.
The y and x intercepts for who?
7y
There.
equals x minus
Yes.
14.
Yes, there it is. We need the equation. That's what goes under line 1, the equation. 7y equals, what did that say? X
Minus
minus
14.
14. So we need to work with this guy. We want to find the equation. Line 1 is all about the equation they give you. And what we want from line 1 is we need to, for step 1, find the slope, because we can't do anything for our line 2 without a slope. So how do we find the slope of this? Is it ready? Do we know what it is?
No, we have to divide 7.
Good. All right. Yes. Very good. What number's in front of my x here?
1.
And that's important to us. So I'm going to write that 1 in. And just like what you said, we're going to divide by 7. And I'm going to divide all my numbers by 7. So y is equal to, what do I get here?
1, 7.
1, 7
X.
minus
2.
2. So what is the slope of line 1?
1/7.
There you go. Now, under the relationship, they told you something about these two lines. What do we know about these two lines? What's the relationship?
That the other one's perpendicular.
They're
So it's -7.
perpendicular. That's right. And then under line 2 will go our point. So line 1 gets the equation. In the middle, the relationship is either parallel or perpendicular. Read it to figure out which one. And then over here goes our point. What was our point again that we had?
4, -6.
4, -6. I don't know why my email is trying to open. So 4, -6. All right. So let's go back and let's finish this up. So this is my setup. I get you to write the equation, put the relationship, and I put the point over here. So step 2 is we're going to use the relationship to find line 2's slope. So the slope for line 2 is going to be what?
-7.
-7.
Yeah.
Because our relationship is perpendicular. So we'll take the opposite, which the opposite of a positive is a negative. And if I flip this, that gets us 7. So there's our slope. Hey, look, there's a point. What are we going to do now?
Point slope form.
point slope. We're gonna write the equation. So we're gonna go y minus y1 equals m parenthesis x minus x1. Y minus, what's our y1?
Is -2 have anything to do with it?
Nope.
No.
Come on, you got a point up here.
Is it negative
Negative
6?
6.
-6. Yeah, it's up here. This is your x1. This is your y1. Our m is
Negative 7?
hers. X minus, what's our x1?
4?
Yay. And as Nick would tell us, two negatives by each other would become a positive. So this is what we have to manipulate. What are we going to do now?
Distribute.
Distribute. So y plus 6 equals -7 times x, -7x. -7 times a -4 is a positive 28. And now what?
Subtract 6.
Boom goes the dynamite, and there's our equation. Y equals -7x, what?
Plus 22.
And there you have it. There's our perpendicular equation. And these are the 3 steps you'll follow. Find the slope from the equation. Use the relationship with that slope to get line 2 slope. And then you got a point, you got a slope, write your equation. Everyone good at number 9?
Yes, sir.
Perfect. Moving on, number 10. And believe me, the second half of this test will speed up a little bit more for you. I know there's a lot of work right now. All right. Number 10. Oh, the dreaded word problem, but it's not that crazy, I promise you. So it says the fruit company recently released a new applesauce. By the end of the first year, profits on this product amounted to $27,700. The anticipated profit for the end of the 4th year is $33,400. After the first year, the ratio of change in time to change in profits is constant. In other words, what they're saying is this is linear. Let X be years and P be profit in dollars. So the first thing we want to do is write the function. Remember in class, I told you guys that word problems for this module generally fall into one of 2 categories. Either they're giving you the slope and the intercept, or they're giving you 2 points. What do you have here? Are they giving us what we need, or are they giving us 2 points?
Couldn't you make like a table or a function table?
You could, you don't have to.
Oh, yeah, okay. They give you, isn't one like a pair would be 1 in 27,000 or?
Yes. So what you're saying, Nick, is they're giving us points, and you're correct. So one of your points is 1, comma, 27,700. Did they give us another point?
4.
Yep.
33,400.
Perfect. So for part A, we're going to take this information that you just gave us. They gave us 2 points in there. And all we got to do is write the equation. Hey, we did this. We did this back in number 8, where you were given 2 points and you wrote the equation. That's all number 10 part A is. You got 2 points, write the equation. So what do we got to do first?
Find the slope.
Find the slope. And as you guys told me earlier, that's y2 minus y1 all over x2 minus x1. Who up here is x2, y2?
4 and 33,000.
Perfect, because that's our second point. These are the ones then, because that's our first point. And I don't know why I put an x2 over there. That's just silly Mr. Armstrong doing dumb things. Let's fix that real quick. Make that a y2 here in a second after it dries. So let's plug in. So our y2 is 33,400 minus our y1 is 27,700 all over our x2 is 4 minus our x1 is 1. I just want to double check those numbers real quick, make sure I wrote them wrong. Okay, they're good. All right, so what is 33,400 minus 27,700?
5,700.
5,700? Come on, pen. Okay. Divided by,
3.
and I believe 5,700 should come out nice and neat if you divide it by 3.
1,900.
Perfect. So our slope is 1,900. Okay. Now what do we do?
Just point slope.
Point slope. Y minus y1 equals m parenthesis x minus x1. And it just so happens that our first point has the lowest values. I would go with those. So we plug in y minus 27,700 equal to 1,900 parenthesis x minus 1. So we distribute, as you guys have told me previously. And we end up with y minus 27,700. And as I distribute my 1,900 through, I get 1,900 x minus 1,900. And then the last step,
Add the 27,000.
you got it. Let's add our 27,700 over. And our equation, y equals 1,900x plus what?
25,800.
I assuming you're adding and subtracting is a-okay, and I'm gonna go with it. Now, remember, they wanted you to use specific variables. So X be years and P be profit. So right here, you can see that in our equation, our Y value is really the P.
Okay.
And we're okay with the plain X that we have in here. So this is the answer to part A. Just putting in that equation. All it was recognizing that in this problem, they gave you 2 points. All right, part B and C are putting your equation to work. That's what part B and C are about. So it says use this function to predict the company's profit. Okay, so we got this P of 9. What are they telling us to do with this P of 9?
Plug in 9 for x.
That's absolutely right. All you're going to do is plug in the 9 and let the calculator do all the work. So 1,900 times 9 plus 25,800. What'd you guys get?
The 1900 part is 17,100, and then you have to add that
Uh-huh,
to
I'll go with it.
25800, 42,900.
There you go. There's the answer to part B. That's the number they want in the blank. Part C. This time they're telling you the profit is 39,100. They want to know what year. So what do we do with this 39,100?
Do we equal it to the equation?
You got it. So this is their profit at the end of the year. Equal it to your equation and solve for X. Like I said, B and C are just going to take your equation. One of them will have you plug into X. The other one will have you plug into Y and solve. So what do we do to solve this? What are we going to do now?
Subtract 25,800
Okay.
from both sides. And then
That gives you 13,300 equal to 1,900 X. And now what?
divide by 1900.
Okay.
It's 7.
So how many years? Yeah, there you go. Good job, Emily. 7 years. In 7 years, that's when they'll have that $39,100 profit. Any questions about number 10? All they did is they gave you 2 points in the problem. You wrote the equation. And then you used your equation in part B and C to get some answers. Good work. You guys are doing great. All right, number 11. So that number 10, again, that one came from writing equations. Came from the writing equations section. So number 11, again, we got 3 parts, but nothing crazy. In part A, they want to know the domain. In part B, they want to know the range. And in part C, they want to know, is this a function? And they give us these points up here.
Domain is
Hold on. I've got to write everything down real quick. But I like the enthusiasm. Now this, always when you write domains as a mathematician, you should be putting these numbers in order. I know it doesn't say it over here, but these numbers should be in order from least to greatest. All right, so domain, who did domain deal with?
the x's.
The x's. So all you need to do is tell me the x's in order.
Negative
Negative
2.
7.
-7,
Negative
And
7.
-7,
then the
-2,
-2,
and
and
4.
4. Remember, we do not write -2 twice because once you say it, it has been said, even though it does repeat. Who does the range deal with?
The Y values.
The Y values. So give me the Y values in order.
1, 8, 8.
1
Negative.
and 8.
What about -8?
Yeah, I was gonna say there's a
Oh,
-8.
there's a -8. Did I miss right? I did miss right.
There's a -8 first.
Hold on one moment. Let me fix that. So now I gotta fix my answer. Gosh darn it, strong. I'll go up there and fix that guy. So yes, there is a -8. So give that a moment. Let's talk about, is it a function? So is
No.
this a function?
No.
No, because -2 is there twice.
Yes, I
So
love
it's
it.
cheating, like you say.
Boom, there it is. You caught. Player got caught. Yeah, Remember, to be a function, x's don't cheat. X's do not repeat. And we have repeating x's here, -2 and -2. It's trying to have two y values, and that's no bueno. Good job. Sorry, just fixing my range answer. There we go. Now I got it. All right, so the range, just so you guys know, just to recap, -8, 1, and 8. And function is a nada. Okay. Oh, no, I'm trying to open up my internet. Sorry. Clicking on the wrong stuff. All right, number 12. So simple question. Is this a function? Yes or no? And it even tells you use the vertical line test.
No.
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 Okay. No. Because if I drew in a vertical line right here, right through the middle of my little vertical oval, I hit two y values. So that means whatever this x value is right here, it's cheating. So absolutely, that is a no.
If it was different like ordered pairs, is there any way like a circle on the graph could be a function?
A circle is never a function
Okay. Just making
because again, when I draw on a vertical line, it's going to hit two y values for certain x values. It's going to happen.
sure. Okay.
Yeah. So circle ovals are never going to be functions. We can talk about them as equations, as you'll see later on when you get into college algebra, but never functions. All right. Same question for number 13. Is that a function?
Yes.
Yes. Absolutely. Because nowhere where I'd be able to draw a vertical line and hit this graph more than once, because this piece right here is going to keep shooting on up and up and up and out and out and out. It's going to keep traveling down the x-axis. It's not going to swoop back in, I promise you. So this thing's just going to keep traveling up to infinity and beyond. And this thing's going to keep going down negative to infinity and beyond. So if I draw in vertical lines, I will only hit my blue function one time. Nowhere where I ever hit it more than once. So this is definitely a function. It passes the test. Whereas in number 12, this one would not pass the test because as soon as I draw on a vertical line right here, it fails because I hit it twice. Good job. All right, number 14. They want to know what is h of -4. So what are they wanting us to do?
In.
Plug in.
So
But
the
up here, they give us three equations. Which one are we plugging into?
h of x.
The h of x. So all they want you to do is to plug into this equation that's right here. Wherever you see an x, put a -4.
I have a
Okay.
question.
Yes.
When you're writing it out,
Oops.
and everything, do you multiply the negative x or whatever the x is by the second power or the 7?
So when you're doing this, when you're evaluating, it's called order of operations, Nick.
Okay.
Please excuse my dear Aunt Sally. So what are you going to do first?
Okay, parentheses.
Parentheses. And what are we going to do with these parentheses right here?
So it's gonna be 16.
We're going to square it. That's right, because the E stands for exponents. So you'll have 7 times 16 minus 7. Now what are you going to do?
7 times 16,
Okay.
which is 112.
And then we're going to subtract 7.
So 105.
There you go. Yeah. Follow PEMDAS. And that's a big mistake that algebra students make, is that you will multiply the 7 and the -4 first and then square it. That's not how it works. You square, then multiply. Exponents before multiplication and division. So there's number 14. On to number 15. See, like I said, the second half of this test gets pretty fast. So here we've got a domain question. Notice that these domains are written in set notation. Okay. But I will also talk about the interval notation for this as well. So we've got this f of x equal to 2x all over 3x minus 7.
Does the domain only have to do with the bottom, the denominator?
So let's talk about that. Remember that when you're writing domain, the first thing you assume is what? What's the first thing you assume when trying to figure out domains?
It has to be greater than 0.
Nope.
All real numbers.
You assume it's all real numbers.
Mhm.
So we assume right now our domain is from negative infinity to positive infinity. Unless we are two specific cases. What are those two cases? What are the two functions we have to worry about?
This might be like a guess, but something to do with the denominator can't be negative.
Okay. And that's what we have here. What is this type of function called?
A rational function.
A rational function. So our domain runs into problems if we have rationals. And what's the second one? Because that's what problem 16 is about.
Root functions,
Say it again.
root functions.
Root functions, square roots, cube roots, fourth roots. So when we have root functions or radical functions, sometimes that's what I call them, or rationals, we have to worry about the domain because it's not all reals. This is a rational. And with rationals, as Nick said, you need to take the denominator and set it equal to 0. Because we want to figure out what number makes this 0. Because can we divide by 0?
No.
No. So if I come out here and I go out to my regular calculator, if I take 8 divided by 0, just to show you, I'm dividing by 0, it says error, division by 0. So we need to figure out where this happens. And in order to figure out where that happens, you take and you set your denominator equal to 0. So we're going to take this 3x minus 7, set it equal to 0, and let's solve. What do we do?
Plus 7.
That's 7.
Okay. So that gives us 3x equal to 7. Now what?
Divide by 3.
Divide by 3. X is equal to
7/3.
7/3, 7/3. This is the number that makes my calculator say error. So my domain then will be, because they're doing set, X is a real number and X cannot be what number?
7/3.
7/3. So you'll choose A and you'll put 7/3 in the blank. So X is a real number and X cannot be 7/3. X can be whatever it wants, but this number. You follow me on that? Does that make sense?
Yep.
So with rationals, you set the denominator equal to 0. If it wanted interval notation, remember rationals look like or answers. And remember, it would start at negative infinity. It would go up to my number. And then it's parenthesis, union, parenthesis. Remember I said when I taught class that I teach that it's like we're jumping over the number. And it almost looks like you start spelling the word jump. J-U.
Mhm.
Okay. And we jump over our number and then we pick up on our merry way towards positive infinity. So that's what the interval notation looks like. And this says the same thing. X can be whatever it wants except for this. This right here means we're going to jump over that number. We don't like it. Everyone good on number 15?
Yes, sir.
Okay. Number 16 takes the other case that Catherine told us about. I believe it was Catherine. And what we have here is this function f of x equal to the square root of x. We want to find the domain. Now on this one, they're giving us interval notation. But I will also talk about the set answer. So what do we do with radicals? Because again, we just talked about this. Catherine told us that radicals also present a problem. Our domain is not all reals. It's not B. So what do we
So
do
you
here?
would take everything under the radical and make it greater than or equal to 0 and
That's
solve.
right. That's right. You take your radicand, that's everything under the radical. So whatever polynomial you have under here, you take that polynomial and you set it greater than or equal to 0 and solve. And that will be the answer. So if I take this and set it greater than or equal to 0, that's it. There's nothing else to do. So remember, if I look at this graphically, that means at 0, I have a bracket and I shade to the right. So what does this look like in interval notation?
Bracket 0 to positive infinity.
Boom. That's the answer you're looking for. And if I wrote this in set notation, it would look like this. Our squiggles, X, line, and then you just put that answer right there in it. X greater than or equal to 0. There's the set notation for it. Once you solve, that's your set notation answer, whatever it is. But that's the answer they want. Okay, whatever polynomials under this, set it greater than or equal to 0 and solve, and that's the answer. But of course, make sure that you look at it through the lens of interval notation. Any questions on number 16? Okay. So in here, all they want you to do is tell me what f of -1 is. But they give us two graphs. One of them is f of x, one of them is g of x. So that means, do I look at both graphs?
Just the f of x one.
Just the f of x one. Which color is that? Blue or red?
Blue.
So we're going to use the blue graph only. And you're going to go to -1 because that's your x value. So remember, basically what they're asking you here
Find the
is they're saying if your x is 1, or sorry, -1, what's the y value? That's what it's asking up here. Okay. If x is -1, what's your y value going to be? So go to -1, find me the y value.
Is it -2?
It's not -2.
I can't really see that.
I know. Let me see if I
Oh,
can.
it's -1. Never mind.
Let me zoom in. Oh, nope, that's what-
-5?
Nope. What is -1 going to be? Zoom in a little bit more. X is -1. What's the y value?
Is it -2?
It is not -2. -2 would be right here.
Oh, is it
Here's-
negative infinity or
Here's
negative?
-1.
Oh, it's +2.
Here's -1.
Is it negative infinity?
It's not negative infinity.
-10?
It is -10. It actually intersects right down here at the bottom.
Yeah, I didn't know if it intersected or not.
Yeah, it did. So at -1, because this is X is -1, where's my graph? Follow it all the way down, and it really is at -10. So that's the answer they want. So again, in here, oh, I see the confusion. Deanna, you have a -1 up here, yet down here it's a +1. So let's do both. So we know what f of -1 was. Let's do f of +1. No wonder I was getting weird answers. So what is f of +1 then?
-2.
That's a -2. There we go. Now I understand why you're all, I'm like, why are you saying -2? Yeah. So, yeah, so just doing both of these, since it kind of looked weird. So this one is asking if X is 1, what's your Y value? There you go. Easy fix. Now I understand the confusion. So we just did 2 of them. Any question about number 17? I don't speak, dog.
Sorry about that.
It's okay. All right. So let me zoom back out so we can keep on rolling. All right. So number 18. So number 18 says the dosage in milligrams, D, of a heartworm prevention for a dog who weighs X pounds is given by that equation. So D of X equals 136 over 25 X. Find the proper dosage for a dog that weighs 27 pounds.
Do you distribute 27 into the x's?
You got it. That's what you're going to do. What they are asking you to do, we've got some dog is 27 pounds. All they want you to do is plug the 27 in. So 136 over 25 times 27. So you just go to your handy dandy calculator. Let me see if it says rounding, because this is important. So it says write it as an integer or a decimal. So that means no rounding.
So it's 146.88.
That's a good question. Let me find out. Double checking myself. So say that again.
I got 146.88.
Perfect. 146.88. And I always like to include labels. So that would be milligrams. So mg. There you go. That's all number 18 is about. Can you take a variable and plug it in? Almost done, ladies and gentlemen. We're on number 19, then number 20. So number 19. Any questions over number 18? Real quick before we move on. All you had to do, take 27, plug it in for X, and kick out an answer. Okay. Number 19, match the graph. Which one of these is the graph of f of x equal to the square root of x?
Is it the V one?
It is not the V one.
Is it B?
It is B as in boy.
How do you find that? I'm just curious.
Okay. So part of being in intermediate algebra is knowing certain graphs. So in my course, I gave my students a handout that had pictures of parent functions. So this is what we call a parent function. But if you forgot what the parent function looks like, go to your calculator. Go to y equals and put it in. Our square root key is above the x squared. So hit second x squared, hit x, graph. There it is.
Perfect.
Okay,
Thank you.
no worries. Give me one moment as I kind of make my makeshift graph. Okay. And then last but not least, number 20 is another quick question about a graph. Which one is the graph of f of x equal to x? Who's the parent function?
The V one.
The V? No.
Wow.
The V1 you keep wanting. That's absolute value.
Absolute value. Okay. Is it A?
It is A. It is A. That is a linear function that I gave you. That is a linear function. Give me just a moment to get mine graphed. And again, if you forget what they look like, go right to your graphing calculator, hit y equals, push x, graph. And there you go.
Awesome.
And that, my good friends, is the exam 1 review, version B.